All right. So number 6 says we're working with regression functions using technology. So the world record time for the men's 100-meter sprint was 10.00 seconds in 1960. The table shows the world record time since 1960. So years after 1960 is how they built their X values. So that's going to be X values because we measure the time. Usually time is X, but the time in this case is the measured stopwatch time for the 100-meter race. So that's what's being measured. And obviously the time, the years are going by automatically. So that's the X. And if you have years like 1960 and then 1968 and so on, you might want to simplify that into maybe years after 60. Or you can do 1,960 and then 1,968 if you want. But you just have to adjust your window. Okay, so as we recall here, we get our calculator up here. And you want to turn that on. I'm going to clear everything. I'm going to go to Stat menu. So Stat, Enter to edit. Okay, so Stat, Enter. Now these lists I'm going to clear because I've used these before, but you hit the Clear button, Enter, and you go over, up, highlight L2. It'll give you a list of everything that's in there kind of thing. You want to clear that as well. Okay. Any questions on that first step? Stat, Enter, clear your lists. Okay, get ready. So I'm using list 1 and list 2. I'll have to keep that in mind for when I tell the calculator which list to draw from. But what you're going to do is you're going to put your X values in for list 1. So I'm going to put in 0, 8, 23, 31, and so on into list 1. So where will I do that? I'll put that over here, so hopefully you can see some of that. Okay, make sure you do put 0, don't leave it blank. 31, 36, 48. Okay, and then when you get all those in, go to your next list and put those ones in. All right, so once you've got all your values in there, you've double checked everything. What you can see by this table of values is that as the years go on, the times get smaller, right? So that means that the athletes get faster over the years, right? For a number of different reasons. Even like the shoes are better, the training is better, right? The diet is better. There's science knows more about how to, improve muscle strength and all that sort of stuff. And there's maybe more dedication for the athletes. They get supported better to do this full time and all that sort of stuff. So it makes sense. Now there would be sort of some kind of limit here, I imagine. And this is a number of years old already, this question, talking about Asafa Powell in 2007. But anyway, so 49, that's 2009 here. Okay, looks like 1960 plus 49 is 2009. So let's save that question for later. Describe create a scatter plot. Okay, we're in the middle of that. So back to your calculator now. So remember we want to do, what are we doing? Second function y equals, which is the stat plots. So you want to hit enter there and make sure that's on. Okay, so hit enter to highlight that. Make sure that the scatter plot is selected and make sure that your X list, we put that in list 1. Make sure that says list 1. If it doesn't, do second function 1 for L1 and so on. Okay, and list 2 is, Y list is list 2. Okay, so the other thing is the window. We might want to adjust our window just because we don't know what's been happening before in this calculator. But X is 0 to 49. So, I mean, if you want to go -1 or something so you can clearly see the 0, and then for the X max, go to 51 or 52 or something just so you can see there. And down to the Y minimum. Okay, well, it looks like the minimum is below 9.58. So let's just go, I don't know, maybe 9. And the maximum, let's go 10.5, just above the maximum value we see there. Whoops, and that would be 10.5. Okay, So now that we've got that, let's graph it, and hopefully, okay, there we go. Look at that. We see that we have a steady decline in the times, and then it looks like a pretty sharp decline as we have a few years where those times dropped quite a bit. Okay? So is anyone having problems with this, or? Okay, so we ran into a problem with the window there. The negative is down at the bottom here, negative, if you want to put in a negative. I'm not sure why, I got alpha. Don't put a minus if you want a negative. So yeah, so I did -1. If you put in a -1, it doesn't like the operation of subtraction. Just a negative, yeah?
Why is x max of 52?
Well, okay, why is x max 52? Because I just want to make sure I can see all of these points on my screen. If you put it as 49, you'll have a dot right on the very edge of your screen, and it's like, eh. So I usually go just before the smallest one, just after the largest one, so I can make sure that I have everything well within the view. Okay? This number, you can put 51 or 55, it doesn't matter, whatever you want, but just something beyond 49 would be advised. Okay, so we've got the scatter plot there now, great, okay? Describe the characteristics, okay, we already kind of did that. As the years go on, the time gradually gets lower, and then in the last few years of measurement, there is a sharp decrease, okay? That would be a great description of the characteristics of the trend. Now determine the equation of the linear regression. So this is where we're at. This is the most important thing. And then we'll ask about the slope and the y-intercept later. So let's go back to our calculator. So again, how we want to tackle that is we want to go to Stat button, okay, and then right cursor over to the Calculate menu. And this will calculate, look at all these reg, see? Reg, 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 reg. That's regression functions, different types of regression functions. We want linear, so line, and it says ax plus b, it's y equals ax plus b. So we're going to hit 4, and this is what should show up on your screen. Now we're not done yet because we have to tell the calculator what lists to draw from. So we're going to say my x values, and you want to put your x values first, was in list 1. So I'm going to hit second function, list 1. Then I'm going to separate that by a comma, okay, so x comma y. And y is list 2, second function, list 2. Before you hit enter, we're going to do one more thing to make our lives a little more simple. Okay? We are going to go now comma again, and we're going to hit vars button, variables. Okay? It's a variable. And we're going to cursor over to y, vars, function. Okay? Enter. So vars, cursor over, right, enter. And this will ask you, where do you want me to put the values for your function? And just do y1 is fine. So your screen should look like this. Again, what we're telling the calculator to do is please use our data for x and y to build a regression function that is a straight line, and please put it in y1 so that it's already put in there. We don't have to type that in again. So it'll come up with this screen now, and you should have these values, something close to this. So A, because these years, there's a lot of years over here and very little change in time, the slope is very slight. So it's negative. That makes sense because the data points go down. So it goes down over time. So we have a negative 0.00665 for a slope. And then our y-intercept is 10.03. So if we hit y equals, you should see it already in there, pre-populated. And there's the line that is the best line of best fit for the graph. All right. Now this point down here, the very last point, is a bit of an aberration, isn't it? It's a bit of an outlier. An outlier would be a point that's drastically different from all the other points or all the other points that build the sort of the trend. Might not be considered technically an outlier because it's not that far out, but it is looking like certainly one that's an aberration. Okay? All right, so let's keep going here with this question. What do the slope and y-intercept of the equation represent in this context? Okay, any ideas what the slope represents? The slope is a, yes. What does that number represent? Oh, okay, rise over run, x over y. Sorry, that's maybe y over x. But yes, okay, yes. But what does it mean? Let me restate it that way. What does it mean in the context of the question, without using all the math, terms really? What does that mean for this question? What does that say about the times of the 100-meter dash sprint over these years? Okay, the average that it changes over the year, you say, every year? Okay, so this would be the yearly change, right? Because it's time, right? It's time change divided by years. So it is the change in the winning time over per year, really, right? It's the change in time divided by years. So it is the rate of change of the winning time over the years. So this is how much exactly that it goes down by every year. The winning time decreases by negative 0.00665 seconds per year on average. So yes, that's a very good answer. The y-intercept, okay, if we look at that graph again, the y-intercept, now it's 0, 10 was our y-intercept for our points, but the line, okay, the line of best fit gives us a slightly different answer, right? It gives us 10.03. 10.03. So what that's supposed to mean would be, given the trend in the data, on average, the time according to our overall trend, the time in 1960 is calculated to be 10.03 seconds. That's not the actual value, but remember, when we look at lines of best fit, this line doesn't go through many points at all, if any. And so that is the best guess for the overall trend. So that will give us confidence to answer other questions like this. Interpolate, remember, interpolate means get data from the line of best fit inside of the data points that are graphed. So interpolate a possible world record time for 2007. So 2007 would be at what, 47 here on this one? 47. So what you do is now you go to, okay, watch this, second function, trace, which is the calculate menu. So this is another calculate menu. It's a different calculation menu than the stat one, okay? But second function, trace, this calculate menu, you just hit number 1 for a value, and that will allow you to plug in an x value. And we're going to plug in 47, which represents 2007. And what this is going to do, now this deals with the line, okay? The stat calculate deals with the points. This calculate menu deals with the line. So if I hit enter, it's going to give me the y value that would show up on the line. So in 2007, our best guess for what the world record time would have or could have been or should have been, given this gradual change, is about 9.72. Okay, so 9.7202, maybe just a little bit different than this one, right? But pretty close to 72, which makes sense. It's right around those other points there. So that would be your answer for that question, 9.7202. Asafa Powell from Jamaica accomplished a world record time on September 9, 2007. Research this time and determine the difference between this time and your estimate. Okay? So Asafa Powell, 2007, maybe we'll look that up here real quick. So his world record time was 9.74 seconds in 2007. So that's about 0.02 seconds off what we calculated at 9.72. Okay, so again, this point was not used in our data calculation, in our calculations there, but 0.022 seconds. So again, it kind of holds with the trend. His dot would not have been way up here or would have been way down there. His dot was really close. His point, his time, really, really close. So I guess that sort of strengthens the idea that, you know what, this is a best guess for the points that you don't know about. Now, the other question I guess we could ask is what would happen, you know, in 2022, right? This year, right? 2022. Well, what we'd have to do is we'd have to use this line to guess. And I'm going to do that real quick. So what I'm going to have to do, though, is extend my window right? So 2022 is going to be what? 40, that's 62 years. So I'm going to go to 65 on my scale. So watch what happens. I have a little bit extra to work with. Now, if this holds true, second function, trace to the calculate menu. All right, so what did I say, 40, 62 is 2022. So 62, the time this year should be 9.62. And again, extrapolating data, extrapolating stuff like this can get you into trouble, right? Because there would seem that there would be a limit to human capabilities of how fast they can run. So most likely this graph is going to flatten out a little bit, right? I don't think it's going to go to 0, which looks like it will, right? In another 100 years, it's going to be at 0. I don't think it's going to be at 0, right? How fast can you get from here to 100 meters away? 0 seconds, just because, you know, we've got so much technology now. No, I think your watch is broken, and that's what's the problem if you got 0 seconds. Yeah, there's lots of stuff. Yeah, but to get it down to 0, you know what I'm saying, right? Like it's never going to go to 0, so there are limits to this kind of study. All right, any other questions about number 6? All right.